Alright, so good morning everyone, and it's good to be back after a couple of weeks. So let's get started with today's weekly contest discussion. Let's see what we had for the contest today. Alright, let's let it load. So the weekly contest number is 384. I'm recording the video today on 2nd February. The time is 11:45 a.m. and yeah, let's firstly just a general overview as we usually do for the contest. Okay, so weekly contest number 384. All right. The contest was more on the easier side today, I would say. Okay. The similar pattern which we have been observing in the past few contests that they give the same question but with different constraints. So that was also seen in today's contest. So yeah, let's get started with the discussion for the problems. Okay. And okay, so we had four problems today. This was the numbering for the problems. Okay, let's see the first problem. We have been given a zero index m into n integer matrix. Create a new zero index matrix called answer. Okay, make answer equal to matrix. Okay, so the new matrices will be equal to given matrix only. Then replace each element with the value minus one with the maximum element in its respective column. All right. So what they are saying is that we need to create another matrix which is same as the given matrix, and in the new matrix we need to replace every element with the value minus 1 with the maximum value of the column of that particular matrix. Okay. So let's say if we have this matrix 2 minus 1 8. Okay. So I'll take minus 1 and I'll replace it by 8. This column would become 288. Similarly, minus 169. Maximum value is 9. So the column would become 969. Okay, this is what they are asking. The constraints are very small. Okay, so of course we can go for an n square solution for this. Okay, and that is what we'll be doing. So again, I hope everyone would have solved this problem. So I won't be wasting a lot of time on this problem. Let's see what we have. Okay. So matrix has been given. Keep that in mind that this is not a square matrix, okay? Just so that because when you are in the contest, you sometimes make this kind of a mistake that you assume that it's a square matrix and you do not read the question properly. So I hope no one made that mistake today. Okay. So let's say this is, although I've taken square matrix only, let's make it as a rectangular one. Okay. Let's add another row. Okay, so what we'll be doing in this question, I hope the problem statement speaks for itself only. Okay, what you need to do is you need to traverse each column. Okay, take the maximum value of each column. Okay, let's say the maximum value are m1, m2, m3, m4, and wheresoever you find a minus 1 in that column, replace this minus 1 by the respective maximum values of that column. Let's say we have minus 1 here. So I'll replace it by m2. Okay, this is all you need to do. So what you will be doing is you will be firstly traversing the matrix by column using a for loop. Okay, traverse the columns. Okay, we have been given, I think, n columns. Okay, so just traverse that. Okay, find maximum. Let's say maximum, initialize it to say minus 1 because all the elements are greater than 0. It has been given. So we need to find the maximum. So we'll initialize it by minus 1. Okay. Now run through the rows. Okay. Row is less than n rows. Okay. R plus plus. Update the maximum value every time. Okay. Max of mx comma whatever that value is. Let's say the matrix is A. So A row column. Okay. Update this thing. Now write another for loop, traversing on the rows only, okay, and replace everything, okay. Replace the minus 1 values by this mx value. This is all you need to do, okay. So this finishes the code and you can return that new matrix answer, or you can, what solution I am suggesting is the in place solution. So you need not make any change, create any new matrices. So it will be a constant space complexity solution. Okay. The time complexity for this solution will be the first loop where we are traversing on the columns and these two loops. Okay. Or rows. Okay. So these are at the same level. So the complexity becomes O of C into R. Okay. In the worst case scenario, let's say we have been given a square matrix for the worst case scenario that the number of columns and rows are equal and it is equal to n. So the solution would become O of n square. Okay. Space complexity is O of 1 because we are not using any additional space. Okay. So that is all about this problem. Let's see the code for this quickly. Okay. So I'm traversing over the columns here. I've used J variable. Okay, and initialize the maximum value with -1. Okay, run the first for loop and update this maximum value in a particular column. Once we get the maximum value, now we need to iterate over the column elements again using this row. So this is actually row iteration and this is column iteration because the column will be fixed but the rows will be changing when you are iterating on the columns. Okay, so yeah, that will be it. And replace the elements which are equal to -1 with mx or let it be like that. Okay. If it is not -1. So that is all. When you run this code, it will get accepted for sure. Okay. So that finishes the first problem. Let's move on to the next one. Okay. Oh, just a minute. Screen is hanging. Give me a minute. It's taking some time. Yeah. So we have been given okay, okay, that's the first problem. Sorry. Yeah. Let's see the next question. Yeah, it's taking some time to load. Let's wait for it. So I hope everyone was clear with the first problem statement. Okay, there should not be any problems, and I'm expecting each one of you who gave the contest today would have solved this question. Okay, it was a pretty straightforward question. Nothing much to think about it. Whatever the problem statement was saying, you just needed to follow those steps. Okay. So it's usually, I think there's not much for me to say on this, but it's usually the same case with the first problem. Very rarely I've seen a tricky first problem in the contest. So yeah, that's it. Yeah. And just to specify that the second and the fourth problems were the same problems. The only difference was with the problem constraints. Okay. So I think that this is taking some time to load. In the meantime, let's move on to the third question. Okay. So we have been given a zero index string array words having length n and containing zero index strings. We are allowed to perform the following operation any number of times. Okay, so we have been given some operation. What operation is it? Let's see. Choose integers I, j, x, y such that I and j is between n. So again, it's the constraint for the array. And x is between 0 and words of I dot length. Okay, so x is an index in the particular string at the ith index. Okay, and y is between y is the indexing in the jth string in the words array. Okay, and we need to swap these two words, words of ix and words of jy. So I hope all of you will be clear with this statement. If not, you can read this once again on your own. You'll get a better idea. So we need to return an integer denoting the maximum number of palindrome words can contain after performing some operations. Okay, so we need to tell the maximum number of palindromes we can get after rearrangements. So first things first, try to visualize this that the order doesn't matter. Only the fact matters whether we can make maximum number of palindromes or not. Okay. So what we'll try to do is we'll do as many replacements as we want because we do not want to minimize our operations. Okay. So we have a clear hand on this that no matter how many operations you make, just get the maximum possible value for the number of palindromes. Okay. Let's see the problem constraints. Okay. So the constraints are pretty easy as well. Okay. Words dot length, words of I dot length. Again, it's very small constraint, so you can kind of go for an n square sort of a solution. Nested for loop. Okay. Let's see what we'll be doing. The idea for this is that you count. Let's move on to the whiteboard. Yeah. Okay, problem three, that's we are discussing. Yeah. So what we'll be doing for this is, think about this, that for all the words, I can maintain the count of all the characters. Okay, the characters are between small a to small z. Okay, so this is the kind of constraint we have for the characters. So this is 26 characters. So we can maintain the count of all the characters across all the strings. That how many times A is occurring, say, in all the strings. Okay, so I can maintain a count for that. How will this help me? Think about this. What a palindrome does is it has the pairs for elements. Okay, so let's say if I have the palindrome A, B, B, A, simple palindrome. So it is having a single pair of A elements and a single pair of B elements. Okay. Or what could happen is something like this is also a palindrome. So this is having a pair of A elements and a single B element. Okay. So think about this that the single character doesn't really matter what character it is. It can be any character. If it's an odd length string and I need to make a palindrome out of it, so the only thing that matters is how many pairs can I make of all the elements, whether the pairs are possible or not. Because the single element can be anything in that case. Okay. And for the even element, there is no such case for a single element for the even length string. So you just need to maintain the number of pairs. So long story short, we just need to count the pairs that can be made out of this. Okay. So what we'll be doing here is that, okay, we'll firstly maintain the count of all the characters, count of frequencies of chars. Okay, all the characters. Once you have this count, what you can do out of it is that you can make pairs out of it. Okay, so how many pairs we can count the number of pairs. Okay, let's say the frequency is f, so the number of pairs possible for that particular character is f by 2. Okay, so let's say we can store it in some variable count for all the characters, sum for all the characters, f of a by 2, okay, plus f of b by 2, okay, and so on. This is how we'll go about it. Okay, once we have this count, next, what we'll do is we need to make the maximum number of palindromes. Okay, maximum number of palindromes, and we cannot change the length of every string in the array. Okay, so the length would remain the same. You cannot switch between the lengths. Okay, so what you'll try to do is you'll try to firstly cover those strings which have smaller length. Okay, so what I can do is I can store the lengths of all the strings. Okay, in another array. Okay, in three and like this, and I can sort it. Okay, I'll sort it, very simple. Okay, once it is sorted, so I'll cover the lengths which I'll cover the strings with lesser lengths first. Okay, this is what my idea is. Okay, and how this will unfold is that, okay, let's say I have some length L and I need to check if I can make a substring out of it. If I can make a palindrome out of it, no matter what characters I use. I have the count of pairs in count. Okay. So what I'll do is how many pairs would be required in this? Irrespective of whether it is an odd length or it's an even length, the number of pairs required is L by 2. So I'll just subtract L by 2 from my count. Okay. That is the number of pairs I'm subtracting because the single character doesn't matter, and I check now if my count is greater than or equal to 0. That means if it is possible to make it a palindrome, because let's say if this value goes negative, that means I did not have enough number of pairs, so I cannot make a palindrome out of it. So only if this value is greater than equal to 0 I can do it. And let's say I'm storing some variable x to define how many palindromes can be made, so I'll just do x plus plus here. Okay, simple. And when I come out of the loop, I'll just return this x variable. That is all I'll be doing. Okay. So let's write a pseudocode kind of thing. Okay. First, a for loop. Okay. For the frequencies. Okay. For all the characters. In fact, this is again a nested loop. Wait a minute. Let's move on to a new page for this. This is getting dirty. So, iterating over the array. Okay. In this loop, then a nested loop for iterating over the string from an array. Okay, so n square loop kind of this goes. Okay, We have the frequency storage here. Let's say in the map by the name MP, we are storing this frequency. Okay, this part is done. I think the first thing is pretty clear. Now let's count the number of pairs. So I'll iterate over my map. Okay, iterator. I'll take for iterating. Okay, and I'll count the number of pairs stored in P. So I'll do P plus equals to iterator dot second divided by 2, this many number of pairs. Okay, I'll store lengths of strings here only. Okay, let's create a vector for storing the lengths. Okay, vector integer len. Okay, so I'll store len में पीछे हम डाल देंगे s dot length. Okay, s I hope you can get it. Okay, so I'll store it here. Okay, the storage is done. Let me take a different color now. Okay, the storage is done. Now I'll sort it. Sorting, this step is very important to store the length vector. Okay, so as you get the smaller lengths first. Okay, now you just need to check for the counts. Okay, that you iterate over this length. Okay, and you check if count minus equals to any value, let's say L of it, and I will subtract, and if it is greater than 0, count is greater than equal to 0, x plus plus. So we'll declare some variable x as well here, initialized with 0, and I'll come out of it and I'll return x. That is all I'm doing. Okay. So at the end you will get your answer. Let's see the code for this. Okay. So again, I'm storing the values not in map. I'm taking a array. So I'll because there are only 26 characters. So if all of you are aware of this technique that you can store the characters in form of indexes. Okay, C character minus a letter A. Because let's say if character is A, so A should come at 0 index. So I hope all of you are aware of this technique. Okay. So this is my sizes vector, this is my pairs variable, and this is my res. That is x, which I have defined in the pseudocode. Okay, so I've named it as res here, result. Okay, iterating over the words vector, iterating over the character of the words, the W string. Okay, and counting the number of pairs here. Okay, pushing that in the sizes, the W dot size, that is the length of each word. Okay, and sorting the sizes now. So coming back to the iterations on the sizes vector now. Okay, so I'll iterate over this and I'll subtract the number of pairs and I'll update the result by this condition if pairs is greater than equal to 0 and I'll return the result. Okay, this is what we'll be doing. Okay, so the complexity for this in worst case scenario would be the space complexity is O of 1 because we are not storing anything, 26 characters only. So it's again a constant space. Time complexity is, let's say the length of the array is n and the maximum length of a string in that is n. So the complexity would be n into n. Okay. Worst case scenario. Let's say we have the array of size n and all these strings have a length of n. Okay. So this would be n into n. Okay. Worst case scenario. So yeah, this will work. Okay, so this finishes our third problem as well. Now let's move on to the second problem. Well, the second and the fourth problems are similar. Okay, so I'll explain you the code and the approach for the second solution, the second problem. But for the fourth problem, the only difference for this would be, wait a minute, I'll turn on my charger. Yeah, the only difference we'll do is the algorithm that we'll be using. Okay. So you are given a zero index integer array nums of size n and a zero index integer array pattern of size n consisting of integers -1, 0 and 1. Okay. A sub array nums of I, j of size m plus 1 is set to match the pattern if the following conditions hold for each element of the pattern. Okay. So what are the conditions? Let's see. The conditions are that if okay, so this is true for every index. Okay, so if the pattern k is one, then what should be the condition that nums of I k should be less than its next element, that is nums of I plus k plus one. Okay, And if it is 0, then the elements, subconsecutive elements should be same. And if it is -1, then the previous element should be greater than its next element. Okay, this is what they are saying, long story short. Okay, so let's firstly, again, let's visualize this on the whiteboard first. Okay, because again, the solution for both of them would be same. The only difference would be for the algorithm. Problem 2 and 4. Okay, so this is our nums. Okay, and this is, let's say, our pattern. Let's take a different color here. Okay, pattern. Okay, so if this is say 1, so what they are saying is that this is the zeroth element. So this element say x and this is y. So x should be less than y. Okay. Now this element is 0. So what they are saying is y should be equal to y here. And if it is -1, so what they are saying is that let's say it could be y should be greater than any here the element which comes in. So it can be x, w, or anything. You can represent it by anything. This is what they are saying. And you need to count the subarrays which hold this condition. Okay, that is all you need to check. The subarrays of pattern which hold this condition in nums. Okay, sorry, the subarray of nums which hold this condition of pattern. Okay, my bad. Wait a minute. Okay. So, yeah, again, the constraints are very small for this problem. Okay. So, what you can do is, okay, I'll tell you a solution which can work for both of them. Okay. Kind of. Okay. So, what you can do is for this array, you can create a new array, say updated pattern. Okay, okay, and you can compare every element that whatever condition holds for them. Like for ith element, if I is less than I plus 1, so then you can push 1 to the this array, this new vector or array, whatever it is. If they are equal, then you push 0, and else you push -1 if this condition holds. Okay. Now think about this. What the condition, what the question simplifies down to. Now you have this updated pattern, okay, which is of the same size as the original pattern. All you need to tell is, no, this is not the same size. Sorry. This is a longer size. All you need to tell is the subarrays from the updated pattern of the same size which which are same as this pattern array. So you need to count the number of subarrays of updated pattern which are same as the pattern array. That's all. That is all you need to do. So I hope the first step you could have done easily. And in a smaller constraints, it is very simple to compare the subarrays. Okay. So what you could have done here is that uh, let's say you start at 0 for the updated pattern now. I hope you have created the updated pattern now. Okay. And let's take size of the pattern arrays s. So you can go till n minus s and I plus plus. Okay. And you will compare. Now the subarray becomes from I to I plus s minus 1. Okay. And you need to compare it with every element of pattern. So this can be done in a nested loop. You just compare the elements. Okay. J is equals to I, J is less than equal to I plus S minus 1, blah blah blah. Okay. Just compare them, and if it is different, then do not, at any point if it is different, then do not add it to the answer, else add it to answer. And store an answer variable, initialize it to 0. So for when you come out of this loop, you just update your answer if they are same. Okay. Same is true. Okay. That is all you need to do. All right. Yeah, so the complexity for this would have been O of n square, and because we are using an additional space complexity of storing this updated pattern, so that would be O of n, space complexity, and n square time complexity. Okay, so this is a common solution. Now, listen to me carefully now. Okay, I'll firstly show you the code, because when I had done this code, in first place, I didn't get that approach. Okay, so I just did it complete brute force. I did not create an updated pattern array. What I did was that I just iterated over the subarrays every time in the second loop, and I compared the conditions directly instead of firstly storing the updated pattern, which would have been a much better solution. Okay, although this is a constant space complexity solution, but I'd still prefer that in a contest you could have gone for that solution. Okay, now why that solution is important, that I'll tell you. Okay, all right. So I hope this thing is pretty clear to everyone. Okay. This is what I'm doing. You can see my code. I'm just comparing that if nums pattern of j is 1 and if this condition holds true, I'm checking for the false condition that this is not a subarray of that. Okay. So I'm checking those that if pattern is 1, then what they had told is that nums of I should be less than nums of I plus 1. This is the ideal condition. I'm checking the reverse of it if they are equal or greater. And this is what I'm doing for 0 and minus 1 as well. Okay, so if and I'll update my for variable to 0 in that case, and if it is 1 only, then I'll update my answer and I'll return my answer. So this is what I'm doing till now. Okay, now why this approach, which I've told on the whiteboard, why this is important is this could help you a lot with the next part of the question. So if you, because in this part the constraints were very small. Now if you go to the next part of it, the constraints would have been nums of length 10 power 6. Okay, that are very bad constraints. Okay, that means you cannot go for an n squared now. You need to take a O of n kind of a solution. Now, there's a prerequisite to the updated part of this. Okay, I hope the first part was clear to everyone from both the approaches. The only difference you need to do in the second part is, say you created the updated pattern. Okay, and the problem still remains, say that you need to check the subarrays of updated pattern which are same as the pattern. Okay, this is the question still remains like this. But now think about this, that earlier you were using n square solution, now you need to go for an n solution, O of n or n log n kind of a solution. So what you can do for this comparison, I hope most of you should be aware of these algorithms. KMP, ठीक है, नथ, मॉरिस, ट्रैट, एल्गो, ठीक है, रेबन कार्प, okay, and there is something like Z algo as well. Although I have not used it much, so I stick to these two algorithms. These are pattern matching algorithms. So you have to use these algorithms for solving the updated part. The solution would still remain the same, but the only difference that earlier you were using an n square solution because you had small constraints, and now when you do not have those constraints, you will have to go for a updated solution. Okay, so you will have to go for a better algorithm, that is O of n kind of algorithm, that is the KMP algorithm or the Ravencart algorithm, it's up to you, or the Z algorithm. So I'm not getting into the specifics of it. You can check the tutorials for any of these algorithms and then the question would be very simple. So this is the prerequisite for the fourth problem. So only if you know these algorithms, any one of them, then only you can solve the fourth question, else not. Okay. So that is why I said that the contest today was on the easier side, because there was a prerequisite to this. The problem was easy, but the only thing is that you need to know any of these algorithms. Only then you can solve it, and most of the people know about it who are good competitive programmers. Okay. So yeah, that's it. So I hope that I'll just show you my code for the last one as well. Okay. Yeah, so this is what I have done in the last. I'm using Raven Card for the implementation. Again, I'm not getting into the specifics as to how I'm doing that. Okay. You can check it on your own. So I'm creating the updated pattern and then I'm applying Raven Card to the after every updation. Okay, that's all I'm doing. So again, that's a very simple problem now once you know Ravencart. So I'll just give you a brief overview of what Ravencart and these algorithms tell. Okay, in a short line. So these are used for string matching. Okay, let's say they give you a pattern string, a long string, let's say 10 power 10. Okay, not 10 power 10. Let's take a smaller string, 10 power 8 something, and they give you a pattern x of length 100. Now you need to tell how many subarrays or the how many substrings of x exist in P. Okay, so either you go for an n square solution of comparing character by character, or you go for a smarter solution of O of n by using any of these algorithms. So this is what these algorithms do. And if you see our problem statement, this is what we need to do here. We need to find the number of subarrays of P in the updated pattern. That's all we need to do. Okay. So yeah. this kind of solves the problem, and you can have a look for the tutorial of any of these algorithms. Although I'm trying to cover these algorithms in the coming videos, separate videos, but a lot of it depends on my work schedule and everything. Okay, so yeah, just summarizing the contest, problem one was somewhere between, I'll rate it as 1 out of 5. Okay. What was the second problem? Second problem was again easier. So again 1 to 1.5 out of 5. The third problem was 2.5, let's say 2.5 out of 5. And the final problem was kind of again 2.5 out of 5 if you know the Raven-Karp algorithm. Okay, Raven-Karp or KNT or Z algorithm, any of that. Okay. So, yeah, this is a summary from my side for today's contest. I hope all of you liked the discussion. Please feel free to give your suggestions and your queries in the chat section. I'll be happy to answer them. And please share these videos with everyone because it gives me motivation to cover more such videos. Because it's very difficult to cover these solutions now when you are working. You have a lot of other work as well to do. So please, that kind of gives me the motivation to continue making such videos. And in case you have any suggestions for any such videos, any particular problem statements, do ping me or leave down that and in the suggestions tab as well because I'll be happy to cover the separate solution videos for each question. Okay, but please share these with everyone, all your friends, so that I can make more such interesting content on data structures algorithms. Okay, so till that time, happy learning and have a great weekend. Let's meet in the next bi-weekly contest probably next week. Okay, cheers and a happy weekend once again. Bye bye.